Since the dawn of aerial combat, a chilling truth has haunted pilots. The first to be seen is often the first to be targeted. In the early days of aviation, pilots relied on their eyes and instincts to spot the enemy. The skies were a dangerous place where being detected could mean the difference between life and death. For decades, speed and agility were the only defenses against enemy radar. Pilots pushed their aircraft to the limits, executing daring maneuvers to evade detection. The introduction of radar during World War II added a new layer of complexity, as pilots now had to contend with being tracked from the ground. Then came a revolutionary concept: stealth technology. Engineers and scientists began to explore ways to make aircraft less visible to radar. This was no small feat, as it required a deep understanding of radar waves and how they interact with different materials and shapes. Imagine a fighter jet, not just fast or maneuverable, but practically invisible to enemy eyes. This idea seemed like science fiction, but through years of research and development it became a reality. Stealth technology transformed the way aircraft were designed and built. This was the promise of stealth, and it would forever change the face of modern warfare. Stealth aircraft like the F-117 Nighthawk and the B-2 Spirit became symbols of this new era, capable of penetrating deep into enemy territory without being detected. Stealth technology is about more than just avoiding detection. It's about creating a strategic advantage, allowing forces to strike with precision and retreat without a trace. The development of advanced radar-absorbing materials and innovative aircraft shapes played a crucial role in this. It's about gaining a critical advantage in combat. Stealth technology allows military planners to execute missions that would have been impossible with conventional aircraft. The element of surprise became a powerful tool in the arsenal of modern air forces. A stealth aircraft can penetrate enemy airspace undetected, deliver a decisive blow, and disappear before the enemy even knows what hit them. This capability has redefined the rules of engagement, making it possible to achieve objectives with minimal risk to pilots and aircraft. This ability to act with impunity has made stealth technology a game-changer in modern military strategy. Commanders can plan and execute operations with a level of confidence and precision that was previously unimaginable. The quest for stealth has driven some of the most innovative and daring technological advancements in aviation history. From the early days of trial and error to the sophisticated designs of today, the journey of stealth technology is a testament to human ingenuity and determination. From the sleek black silhouette of the F-117 Nighthawk, which was the world's first operational stealth aircraft, to the futuristic design of the B-2 Spirit, which can carry a massive payload while remaining virtually undetectable, stealth aircraft have captured the imagination and redefined the possibilities of aerial warfare. These aircraft are not just tools of war, they are marvels of engineering representing the pinnacle of what is possible when science and technology come together. But the story of stealth technology is not just about cutting-edge aircraft, it's about the relentless pursuit of invisibility in a world where detection can mean destruction. The ongoing advancements in stealth technology continue to push the boundaries, ensuring that the skies remain a domain of strategic advantage. The impact of stealth technology extends far beyond the battlefield. It has influenced global military strategies, leading to new doctrines and tactics that leverage the unique capabilities of stealth aircraft. It has fueled a global race for technological superiority, with nations investing heavily in developing their own stealth capabilities. The competition to achieve the best stealth technology has spurred innovation and collaboration across the globe. The evolution of stealth technology is a testament to human ingenuity and the relentless drive to push the boundaries of what's possible. As we look to the future, the quest for invisibility will continue to shape the skies and redefine the art of warfare. Stealth technology, in its essence, is the art of deception. It's a fascinating blend of science and engineering that aims to make aircraft less visible to enemy radar systems. This technology has revolutionized modern warfare, allowing aircraft to operate in hostile environments with a significantly reduced risk of detection. It's not about making an aircraft truly invisible, but rather about minimizing its detectability by enemy radar systems. By reducing the radar cross-section, or RCS, of an aircraft, stealth technology makes it appear much smaller on radar screens, often blending into the background noise.
Radar, which stands for radio detection and ranging, works by emitting radio waves and analyzing the echoes that bounce back from objects. These echoes provide information about the location, speed, and size of the object. The challenge for stealth technology is to manipulate these echoes in such a way that the aircraft becomes difficult to detect. Stealth technology aims to manipulate these echoes, making an aircraft appear much smaller or even invisible to radar. This is achieved through a combination of design techniques and materials that absorb or deflect radar waves. The key to understanding stealth lies in the concept of radar cross-section, or RCS. RCS is a measure of how detectable an object is by radar. It's not just about the size of the aircraft, but also its shape, materials, and even the angle at which radar waves hit it. RCS is a measure of how detectable an object is by radar. A smaller RCS means that the aircraft reflects less radar energy back to the source, making it harder to detect. This is crucial for military aircraft operating in enemy territory. A larger RCS means a stronger radar reflection, making the object easier to detect. Traditional aircraft have a larger RCS, which makes them more visible to radar systems. Stealth aircraft are designed to have an incredibly low RCS, minimizing the amount of radar energy they reflect back to the source. This is achieved through a combination of shape, materials, and other design features.
Achieving a low RCS involves a combination of specialized materials and innovative design techniques. Engineers and scientists work meticulously to create surfaces that absorb radar waves and shapes that deflect them away from the radar source. Radar absorbent material, or RAM, as the name suggests, absorbs radar waves, preventing them from bouncing back to the radar receiver. These materials are often made of composites and coatings that are specifically designed to reduce radar reflections. These materials are often applied to the surface of stealth aircraft, further reducing their radar signature. The application of RAM is a critical step in the manufacturing process of stealth aircraft.
The shape of a stealth aircraft plays a crucial role in minimizing its RCS. The design is carefully crafted to ensure that radar waves are deflected away from the radar source, rather than being reflected back. Sharp angles and edges are avoided, as they tend to scatter radar waves in multiple directions. Instead, stealth aircraft feature smooth, flowing lines and curved surfaces that deflect radar waves away from the source. This design philosophy is evident in the iconic, almost alien-like shapes of stealth aircraft like the B-2 Spirit. The B-2 Spirit, with its distinctive flying wing design, is a prime example of how shape and materials work together to achieve stealth.
Stealth technology is not a one-size-fits-all solution. Different aircraft may require different approaches to achieve the desired level of stealth. This involves a complex interplay of materials, science, aerodynamics, and electronic warfare. Engineers must consider various factors, including the aircraft's mission profile, the types of radar it will encounter, and the operational environment. The effectiveness of stealth depends on various factors, including the frequency of the radar used, the distance between the aircraft and the radar, and environmental conditions. Different radar systems operate at different frequencies, and stealth technology must be tailored to counter these specific threats. The distance between the aircraft and the radar and environmental conditions, weather conditions such as rain or fog, can also affect radar performance and the effectiveness of stealth technology. However, when employed effectively, stealth technology provides a significant tactical advantage in the ever-evolving landscape of aerial warfare. It allows aircraft to penetrate enemy defenses, gather intelligence, and carry out missions with a higher degree of safety and success. The pursuit of stealth technology began long before the advent of sleek, black fighter jets. It was a journey marked by innovation, secrecy, and the relentless quest for an edge in aerial warfare. In the shadowy world of Cold War espionage, where every piece of intelligence could tip the balance of power, the need for an undetectable reconnaissance aircraft was paramount. The skies were a battleground of their own, with each side striving to outmaneuver the other. This pressing need gave birth to the U-2 spy plane, an aircraft that would become legendary in its own right. The U-2 was a pioneering aircraft that, while not truly stealthy, laid the groundwork for future advancements. Its design was revolutionary for its time, pushing the boundaries of what was possible in high-altitude reconnaissance.
The U-2, with its long, slender wings and high-altitude flying capability, was a marvel of engineering. It was designed to fly above the reach of Soviet interceptors and surface-to-air missiles, making it a formidable tool in the intelligence-gathering arsenal. While its design did not incorporate advanced radar-evading features, its high operational altitude made it difficult to detect and intercept. This was a significant advantage in an era where radar technology was rapidly advancing. The U-2's ability to operate at such high altitudes provided a level of security and operational effectiveness that was unmatched at the time. The U-2 demonstrated the strategic value of minimizing detectability, paving the way for more sophisticated stealth technologies. It was a clear indication that the future of aerial reconnaissance lay in the ability to remain unseen. This realization spurred further research and development, leading to the next major leap in stealth technology.
The real breakthrough in stealth technology came with the development of HAV Blue, a top-secret experimental aircraft that served as the precursor to the F-117 Nighthawk. HAV Blue was a radical departure from previous designs. It was the first aircraft to fully embrace the principles of stealth design, incorporating faceted surfaces and radar-absorbent materials. These innovations were based on the theories of Pyotr Ufimtsev, a Russian physicist who had developed equations for predicting the reflection of electromagnetic waves by objects. Ufimtsev's work provided the theoretical foundation for the design of aircraft that could evade radar detection, a concept that was revolutionary at the time. His equations allowed engineers to design aircraft with surfaces that would deflect radar waves away from the source, making them nearly invisible to radar. This was a game-changer in the field of military aviation, and it all started with the HAV Blue program.
The HAV Blue program was shrouded in secrecy, with its very existence unknown to the public for many years. This level of secrecy was necessary to protect the groundbreaking advancements being made. The aircraft's unusual angular design, which seemed counterintuitive at the time, proved to be remarkably effective at deflecting radar waves. This design was a direct application of Ufimtsev's theories. HAV Blue's successful test flights marked a pivotal moment in the evolution of stealth technology, demonstrating the viability of creating aircraft with dramatically reduced radar signatures. These test flights were not just a proof of concept, they were a validation of years of theoretical work and practical engineering. The success of HAV Blue demonstrated that it was possible to create an aircraft that could operate with a dramatically reduced radar signature, changing the landscape of aerial combat forever. The lessons learned from the HAV Blue program would prove invaluable in the development of the F-117 Nighthawk, the world's first operational stealth aircraft. This aircraft would go on to redefine modern aerial warfare. The F-117 Nighthawk was a direct descendant of HAV Blue, incorporating all the stealth technologies that had been pioneered in the experimental program.
The journey from the U-2 to HAV Blue highlights the iterative nature of technological innovation, with each step building upon the successes and failures of its predecessors. It is a testament to the relentless pursuit of advancement in the field of aviation. This journey is a reminder that innovation is a continuous process, driven by the need to overcome challenges and achieve new heights. The legacy of these pioneering aircraft continues to influence modern stealth technology, shaping the future of aerial combat.